Imagine relying on a map for 50 years, using it to guide every journey, every decision, only to discover, after all that time, that you've been holding it upside down. Every direction you thought was north was actually south. Every path you trusted was leading you the wrong way. It sounds like a nightmare, but in the world of science, this kind of revelation is not only possible, it's essential. That's exactly what just happened in the field of space science. A fundamental belief, held for decades, has been turned completely on its head by a single, groundbreaking discovery. For generations, scientists thought they understood a basic rule about Earth's magnetic shield. The magnetosphere, that invisible force field that protects our planet from the sun's harshest radiation and charged particles. We built entire branches of technology, launched satellites, and developed theories based on this rule, confident that our understanding was solid. It shaped how we explored space, how we protected astronauts, and even how we designed our power grids. But now, new research from a team of brilliant scientists in Japan has flipped this long-standing idea upside down, forcing the scientific community to take a fresh look at everything we thought we knew. These researchers discovered that the electrical charges on the two sides of our planet's magnetic bubble, the morning and evening sides, are actually the exact opposite of what we believed for half a century. But here's the thing, this isn't a failure. In fact, it's science at its absolute best. Science isn't about being right all the time. It's about being willing to question, to test, and to change when the evidence demands it. The morning side of the magnetosphere, which faces the sun as Earth spins, is actually negative, while the evening side, trailing in the planet's shadow, is positive. This is the exact reverse of what textbooks have taught for decades. This discovery doesn't just tweak a detail, it forces us to rethink decades of knowledge, to revisit old experiments, and to question the foundations of our understanding. It's a powerful reminder that science is about asking better questions, not clinging to comfortable answers. Every time we challenge what we think we know, we open the door to deeper understanding and new possibilities. The magnetosphere, our planet's invisible shield, has a morning and evening side as it faces the sun, constantly shifting and interacting with solar winds and cosmic forces. For 50 years, scientists believed the morning side was positive and the evening side negative. This idea was so deeply rooted that it shaped generations of research and technology. But now, new data from advanced satellites and careful analysis proves the opposite is true. The evidence is clear, and it's changing everything. This isn't just a minor correction, it's a total reversal, a dramatic plot twist in the story of space science. Science is a dynamic, self-correcting process. It thrives on new evidence, on bold ideas, and on the courage to admit when we've been wrong. When new evidence challenges old ideas, we must be willing to redraw the map, to update our models, and to embrace the unknown. So, let's dive into this incredible scientific detective story, a journey that proves getting it wrong is sometimes the best thing that can happen in science, because it means we're one step closer to the truth. Before we get to the big mistake, let's talk about the magnetosphere. This fascinating phenomenon is one of Earth's most crucial features, yet it remains invisible to the naked eye. It's Earth's invisible shield, generated by swirling molten iron in our core. This dynamic movement creates a magnetic field that extends far into space, enveloping our planet in a protective cocoon. Without it, life on Earth wouldn't exist. Solar wind would strip away our atmosphere and oceans. Imagine a barren, lifeless world, much like Mars, where the absence of a strong magnetic field has left it vulnerable to the sun's relentless assault. The magnetosphere deflects most of the sun's charged particles, protecting us from deadly radiation. This deflection is not just a protective measure, it also creates the stunning auroras that dance across polar skies. On the sun-facing side, it's compressed. On the night side, it stretches into a long tail. This tail, known as the magnetotail, plays a crucial role in space weather phenomena. This shield creates auroras and shapes space weather, which affects satellites and power grids. Space weather can disrupt communications, navigation systems, and even power supplies on Earth. The magnetosphere is the barrier between our habitable world and the vacuum of space. It ensures that our planet remains a sanctuary for life amidst the harshness of the cosmos. That's why a discovery that changes our understanding of it is monumental. Such discoveries can lead to advancements in technology and a deeper comprehension of our place in the universe. It's not just a scientific curiosity, it's essential for life. The magnetosphere's influence extends beyond mere protection. It is integral to the very fabric of our existence. Understanding how it really works is crucial for our technology and safety. As we rely more on satellites and space-based systems, comprehending the magnetosphere's behavior becomes increasingly vital. Now, let's see how our understanding went wrong. As we delve into past misconceptions, we uncover the journey of scientific discovery and the ever-evolving nature of our knowledge. For 50 years, scientists believed the magnetosphere worked like a giant battery. The morning side was thought to be positive, the evening side negative. This idea shaped textbooks, computer models, and satellite designs. Early satellite data seemed to support this, so the theory stuck. But it was based on limited low-resolution observations. Scientists assumed plasma moved in a way that matched this electric field model. The problem? Assumptions aren't facts. For decades, this model guided research and technology. But what if the battery was wired backward the whole time? No one questioned it, until now. The answer has sent shockwaves through the scientific community. Let's see how the truth finally came out. The breakthrough came from Japanese researchers using modern satellites like ARES and Themis. They weren't trying to overturn a theory, just build a better model. High-resolution data revealed something shocking. The charge distribution was the exact opposite of what textbooks said. Negative on the morning side, positive on the evening side. The team double-checked everything, but the data was clear. They combined observations from multiple satellites, mapping the magnetosphere in detail. Every new piece of data confirmed it. The old model was backward. Publishing their findings caused an immediate stir in the scientific world. It was like discovering all the star charts were printed in reverse. The Japanese team's rigorous approach set a new standard. Their discovery opens a new era in understanding Earth's magnetic environment. Now let's explore what's really happening up there. So, what's actually causing the charge separation? The answer: plasma motion, not just electric fields. The magnetosphere is filled with plasma, ions and electrons. As solar wind pushes the plasma, heavy ions and light electrons move differently. On the morning side, mobile electrons gather, creating a negative charge. On the evening side, heavier ions dominate, making it positive. This is the opposite of the old theory, and it matches the new data. Early scientists oversimplified, treating plasma as uniform. Now, we see the true complexity and the real electrical picture. Why does this matter to us? Our satellites operate in the magnetosphere's charged environment. For years we designed them based on the wrong charge distribution. If a satellite expects positive but gets negative, it can suffer electrical damage. This discovery could explain past satellite failures. It also changes how we predict space weather, solar storms that can disrupt power grids and communications. Our old models were built on the wrong assumptions. Now, we can build better forecasts and protect our technology. One small correction has a huge impact on our high-tech world. This discovery means rewriting textbooks and rethinking decades of research. Future scientists will learn a new story. Negative dawn, positive dusk. Professors must explain how science got it wrong, and why that's a good thing. Old research must be re-examined. Some conclusions may change. It's like finding a bug in a computer's operating system. You have to check everything built on it. The real excitement is in building new models with the correct physics. We'll finally understand mysteries like auroras and energy transfer from the sun. This is science in action, revising, improving, and moving forward. Every field has moments like this, when new evidence changes everything. It's not failure, it's progress. And it's what makes science endlessly fascinating. This story is more than just a cool space fact. It's a window into the way science really works, and why it's so important to keep an open mind. When we look up at the stars, we're not just seeing distant lights, we're glimpsing the unknown, and that curiosity is what drives scientific discovery. Science isn't about always being right, it's about searching for the truth, even if it means questioning what we thought we knew. Sometimes, that means overturning old ideas that once seemed unshakable. The process is never-ending, and that's what makes it so powerful. History is full of these moments, like when we discovered the Earth isn't the center of the universe, or when Galileo's telescope changed our view of the cosmos forever. Each breakthrough was met with skepticism at first, but eventually, the evidence won out. The old magnetosphere model wasn't foolish or misguided. It was simply the best explanation we could come up with, given the data and technology available at the time. Every generation builds on the work of those who came before. As our tools and technology improve, so does our understanding of the universe. New satellites, more powerful telescopes, and advanced computers allow us to see things our ancestors could only dream of. The Japanese team trusted new data over tradition. That's the heart of good science. They weren't afraid to challenge old models, because they knew that progress depends on asking tough questions and following the evidence wherever it leads. Science has a built-in error correction system. Through peer review, debate, and constant testing, mistakes are caught and corrected over time. When errors are found, they're not hidden or ignored, they're fixed, openly and transparently. This honesty is what makes science trustworthy and reliable. Every overturned theory, every correction, is a victory for knowledge. It means we're getting closer to the truth, step by step, discovery by discovery. So stay curious, ask questions, and be ready to change your mind when new evidence comes along. That's how you become a true scientist, no matter your age. Discoveries like this are just the beginning of new chapters in our understanding of the universe. Who knows what we'll find next, as long as we keep exploring and never stop wondering.